So looking at this one over here, I had a lot of people do something in this one that made it a whole lot harder than it needed to be. Look at specifically this piece. What does it have? It has a GCF of 3. 3 times x plus 3. So when we're multiplying by that least common denominator, we only need to multiply by 3 times x plus 3. We did not need to wind up with a quadratic on this one. So those of you that wound up having a factor on this piece, you went the hard way. Multiplying every term by that least common denominator because things will simplify out. My x plus 3 cancels out. On this one, my whole denominator cancels out. So we're winding up with x plus 3, 1 times x plus 3, plus 1 times 3, which is 3, equals 1. So we can finish this just since we're here instead of leaving it unfinished. So this is x plus 6 equals 1. So what does x equal? -5. Sometimes I'm just waiting for more than one person to say it. Sometimes I can't hear it. Okay? So I had a lot of people multiply by 3 and x plus 3 and 3x plus 9. And we wound up doing a lot of distributions. I had several people wind up using quadratic formula here. You should have wound up with a linear. Like, it did not need to be that super duper hard. Just below this one, when we were writing our notes, if I made this jump right here, would you guys find that sufficient amount of notes? And why the heck would you leave that as a sufficient amount of work? I had several people jump from a quadratic that had a coefficient in front to a factored form that had 2 terms like this with nothing else shown. That is not enough information. How the heck did you do that in your head? I can't do that in my head. And I haven't factored in for years. Show me your secrets.
Wait, do we use quadratic formula for this?
You don't need to use quadratic formula. You can use our x in our box.
Well, I don't use the x because Miss Courtney just taught us how to like do
So there are ways to do it, but you got to show me more than that jump. Even if it's just showing the x, even if you're show me something. Give me something, because I have no idea what wizardry you just did because you teleported. That is too big a jump. Give me more. You got to let me into your brain so I can see what's happening. If I could read your mind and see the path you took, great. I would be happy with that, but I cannot do that. On the top right-hand one, I had several people do a funny distribution thing on this. On this one, so this would be like in the story problem one that we all panicked on. When we have decimals, you can always multiply, and a lot of people did, to get rid of the decimal. So we'd multiply by 10 on both sides, right? This side by 10 and this side by 10. We got the left side just fine, where it would be 3x plus 7y. On the right-hand side, everything's being multiplied. Don't distribute. 50 times 0.3 times 10. So you can either do it as 50 times 3 or 500 times 0.3. Do not do it as 500 times 3. It is not the same thing. When it is all being multiplied, it's just being multiplied. Do not distribute. I had a lot of people do that. And then a slightly different but the same kind of problem on the bottom one, where we would take this 2 and distribute it like this. And that's not right either. So you can either distribute the 2 and the 3 individually like this, That's okay. Or you can simplify our multiplication and make this 6 times x plus 1. But do not distribute the 2 to the 3 and the x and the 1. So a lot of just very small order of operations issues.
We do 3x plus 3.
You could absolutely do 3x plus 3 as a quantity times 2. That would be doing a distribution like the pink and purple I have up there. It'll get you to the exact same thing. So there's lots of different paths through it, but you got to make sure we pick a path instead of trying to do all the things. One last thing about the quiz before we move on. When y'all are writing your answers, I need you to be very intentional about how we write stuff. I am not intending to call out anyone individually. These are actual numbers that were written on actual quizzes. Like this one. That could be a 10 or that could be a 16. I was like, what if the answer key said it was a 10? What if the answer key said it was a 16? Am I supposed to read your mind and figure out which one? These two were for the same question, 64, 66, or 74, 76, or 78. They all kind of look like all of them. Yeah, but I shouldn't need to take the right answer. We're not hedging our bets. Because this one, if the answer key said 14, I 100% could see that. If the answer key said 19, which it did, for these two people, like, because there's a couple different forms. For some people, if it said a 19, I could kind of see it being a 19, but it sure as heck looks more like a 4. And this one, what if I told you the right answer had a 7 in it for this step?
That one, I think that was a 4.
That looks like a 4, but what if it's supposed to be a 7? Is this a 4, a 9, or a Y? Okay, so please make sure, especially when you're writing your answers, the ones that are circled in your work, I don't care if it's messy. Like, I don't care. I can try and follow the train of thought of chaos. But when you're at your final answer, please write it so that people not inside your head can read it. Okay? I should not be trying to guess what you meant when looking at your answers. I should be able to read your answers and not try and guess. Okay? So, again, I only took very, very small pictures so that we could not be like calling anybody out. This was not intending to call anybody out. These were only a small selection of the ones that I picked. So, like, please just be intentional with how we write. Okay. Moving on. Now we're going to go into the notes that are going to finish out 4-4. Or, sorry, 2-4. So this will, I think this finishes out 2-4. Yeah. All right. So we're going to be working with square roots of negative numbers. And 100%, I just heard a couple people start thinking this through. Use I. Switch them to I's. We're a little bit more comfortable with those than dealing with the negative square roots.
Wait, if you separate the I and 36, they wouldn't be together, right? They would be separate because
they're all being multiplied, so they're all, just leave them together.
okay.
Because I can rewrite this fraction square root of negative 36. How can we rewrite that? 6i, or I square root of 36, but square root of 36 is 6. How can we write the square root of negative 9? 3i. And square root of negative 100? 10i. These are all being multiplied together. So let's simplify this. My numerator's not really going to change. It's going to be 6i for right now. What's my denominator going to be? 30i squared. What does I squared equal again? -1. So this is 6i over 30 times -1. So we have, at this point, 6i over -30, or we generally don't like to have negatives in the bottom, -6i over 30. Is there anything else I can do here? We can simplify. Both of those are divisible by 6. Yep, the negative's going to hang. 6 divided by 6 gives me 1i, which you can put the 1, or you can just have it as I, over 5. So you can either write it as -1i over 5, or -i over 5, I over -5. Feels icky, but you can do that. Okay, so when they have negative numbers like this, just switch them out for i's. All right, let's do the next one. It's a very similar vibe. When we switch these negative radicals to i's, we gotta be careful. So this first one up here, square root of -36. 6i. Our square root of -49, 7i. And our square root of -16, 4i. So when we simplify, what are we going to get? (42i squared) over 4i. So we're going to need to do some simplifying. So let's simplify first. We know that I squared equals -1. 42 times -1 gives me -42 over 4i. Let's simplify. -21 over 2i. Do we have a radical in our denominator? Yes, we do, because I is made up of square root of -1, right? So we have to rationalize this, meaning I need to get the radical out of my denominator. So we're going to take this fraction and we need to multiply it by something that's going to make that I no longer be in the denominator. So, do we need to have the 2? So this is my fraction that we had. What is the piece that has my radical in it? The I. 2 doesn't have a radical in it, so we don't have to deal with the 2. You can, but it's going to give you more simplification to do. So all I need to do is multiply this by I over I. You can do 2i. You're just going to put it back at 42 over 4 and then have to simplify that part again. So when we multiply those two pieces together, I get my -21i over 2i squared. I squared we already know is -1. So that's -21i over -2. which those two negatives are going to cancel out. And we're going to have 21i right on the edge right there over 2. That's our answer. I know it's right on the edge and kind of small. So when they give us negatives under the radical, switch them to i's. Okay? All right, we're going to practice more with these square roots of negative numbers. We're simplifying these. They have a whole section about these, and all we're going to do is treat them the exact same way. We're going to switch them to i's. Then we're going to rationalize. I's, simplify, rationalize. So we've got here our first one is 7 plus the square root of negative 64 over negative 2 minus the square root of negative 81. So the first thing we want to do is switch these over to be i's. So I should have 7 plus, what's this one going to be? 8i. Our denominator is going to be that negative 2 minus 9i. And then we're into exactly what we did last week, where we need to multiply and get the i's out of the denominator, and that's when we use our conjugate. I was so excited this weekend. I got my first homework in grad school, and it was literally all about the conjugate. I was like, yay! So this gets used all the way up through like grad school level courses. The class I'm doing is going to be taking these, and we're going to be doing all kinds of calculus with these numbers. So you use these all the way up through. So when we're looking for our conjugate, that's when we take our two same terms in our denominator, because we care about rationalizing our denominator. So I'm going to have my negative 2 and my 9i. And the piece that's different is we change our sign. So instead of being negative 2 minus 9i, it's going to be negative 2 plus 9i. And I'm going to multiply the top by the same value because I cannot change my expression. It does not have an equal sign, so I can't multiply both sides of an equal sign. I have to multiply by a 1. So we're going to multiply this out. Our numerator, we need to multiply these two pieces together. This is where we get our double distribution. 7 times negative 2 gives me negative 14 minus 16i plus 72i squared. Why did I do it in that order? That was a choice. I'm going to switch it back to the regular order. 16, the 9 times 7, giving us our 63. I don't know what's going on with my pen. It just like randomly changed colors on me there. 63i plus 72i squared. And our denominator, we wind up with our 4. We've got our plus 18i minus 18i minus 81i squared. So that's doing all of our distribution there. We can absolutely combine like terms. If you do that multiplication and you wind up straight here, that's totally fine with me, because we should wind up with negative 14. Combining our like terms, how many i's do we wind up with? 47i. And we have our 72i squared. I equals negative 1, so this is the same thing as minus 72. And our denominator winds up being 4 plus 81. And we're almost done with this one. We got to finish our simplifying here.
Do we have to show you the plus 89 minus 89?
No, you don't have to do that. I would 100% okay if you jump straight from here to here. That's totally fine. You guys can absolutely do that multiplication. And I know a lot of us can combine those like terms in our head. I'm totally fine with that. It's the factoring entirely in your head that I need you to give me a little bit more on. So what do we get as our final answer when we simplify this? Negative 86. Does this have an I on it? Plus 47I over 85. So splitting this into our two pieces where we have our real term and our imaginary term. 86 85ths, negative 86 85ths plus 47 85ths I. Questions on any of those pieces? I know it was a whole lot of stuff. What's up? That came from our 4 plus 81. Just drawing a barrier between those two so I don't wind up crashing into it. Because we're going to do the right one in almost in the exact same way. We're going to write it in terms of i's. We're going to multiply by the conjugate. We're going to simplify. So when we write this in terms of i's, I've got my numerator of 4 plus square root of negative 81. So 4 plus, what is that going to be in terms of i's? Nine I. And our denominator is going to be 2 minus 3i. So we're simplifying those radicals by making them be imaginary terms. So we need to multiply by our conjugate to get I out of our denominator. So what is the conjugate going to be? Exactly right. It's 2 plus 3i over 2 plus 3i. You have to multiply it by a 1. Do not just multiply the denominators. So now we're going to do this multiplication. What do we get when we multiply this out? Super duper careful. Yeah, super duper careful because 4 times 2 is going to give me 8. And then we have our plus 2 times I plus, or 2 times 9i, 3 times 4i. So we have 18i plus 12i. So we're going to have plus 30i. I am okay with you doing that jump right there. That's totally fine. That's the 9 times 2 plus the 3 times 4 in the same step. And then they added those together. So that was this one and this one to make this one. And then we have our 9i times 3i to give us plus 27i squared. And if you want to switch that to your -1 on that step, I'm okay with that too. Like, that's okay. And our denominator, we can also go straight to our perfect square form. 2 times 2 would give me 4. Ooh, that's, yeah. 2 times 2 gives me 4. 3i times 3i gives me minus 9i squared. And you can do it as minus 9i squared, minus 9 times -1, plus 9. I'm okay with you making any of those jumps. Our simplified form. I would also be okay with this jump here. What are we going to have as our real number portion of the answer? -19. What is our imaginary portion? 30i all over 13. Which I'm going to do these as 2 separate fractions. It's good grammar to do so. -19 over 13 plus 30i over 13. These are the best ways to write our answers, is separate it out. The one next to it is not wrong, but better grammar has you separating them.
So we have to separate it.
There will not be points off, but when it comes time for using them later, it makes it easier if we're in the habit of it. Okay. So we have kind of one last part of playing with our imaginaries, and that's where we're getting them from and where these kind of statements are coming from. So we're going to be solving and winding up with imaginary answers. So we're going to solve a couple of quadratics. So I had a lot of people that just straight up did quadratic formula for every single time we're solving, which is fine, but it's sometimes going to be longer and more challenging. I recommend checking to see if we can factor every time. It's not going to always happen, but it can, and those are easier usually. So let's double check just in case we're hoping that for that. We want to know if a pair of numbers multiplies to make 13 and adds to make -6. Did any do that?
Yep.
Boo.
Like, to me, that doesn't make sense in my way. Like, the X thing, I don't get it. That's why
Okay. That's fine. Just give me something other than a teleportation. When our A is 1, I totally get us hopping straight into factored form. But if A is not 1, I don't know where you magically came up with these numbers. Like, we're just teleporting. So give me something. Or show me your wizard ways. So this one doesn't factor, so we can't do factored form. So we're going to use our quadratic formula. X equals -b plus or minus the square root b squared minus 4ac divided by 2a. You need to know it. You need to have that memorized. So when we're filling this in, I do tend to put it in double signs and all exactly as it exists. Where my A is 1, my B is -6, and my C is 13. So X equals -b would be -6. That is a weird 6, but that gets the vibe. Plus or minus the square root of -6 squared minus 4 times A times C. You do not necessarily have to do the writing it out step. If you start simplifying it in your head while you go, that's fine. I do recommend it, especially when we start having sign games in there. Like, I've got a couple double negatives, I've got a square of a negative. So I recommend it for keeping track of your signs, but it is not necessarily required. So when we're simplifying this, because especially since we don't get to use calculators, it does help to do it in smaller chunks. The opposite of negative 6 gives me positive 6. What are we getting under the radical? I heard many choices there. Negative 16 should be where we landed. If you did not just get negative 16 on your first try through that, I recommend doing it then in 2 steps. Do your b squared and your 4ac and then subtract them. We would get 36 minus 52, giving us negative 16. Ooh, I heard a what on that. So I'm going to do a mid step here. Square root. 6 squared gives me 36. 4 times 13 is 52. 36 minus 52 is where we got that negative 16. Did that clear up the what? Because I heard a what. So let's simplify this. This now looks just like the ones we did at the start of today. 6 plus or minus 4i. We can simplify this one. Y'all, I need the chitter chatter to die down. Yep, x equals, and we can split it to be our 6 over 2 plus or minus 4i. You can absolutely do it that way too. Totally fine. If you can spot it without splitting it, that's okay too. Because this should give us 3 plus or minus 2i. I do not care if you do the top arrow or the bottom arrow. But we need to wind up down here. You can take a sideways pass through it, or you can make the jump. I'm okay with either of those. So that's where these are coming from. And when we say solve, when the instructions say solve, I had a couple people make this mistake too. Solve does not mean factor. Solve does not mean put in factored form. Solve means get me to x equals. If you are solving and you did not wind it in x equals, you are not done. X equals, not 2x equals, not this factored form equals 0. X equals is what it means. All right. Questions on that first one? All right, let's do this next one. I'm trying to give myself a barrier again. I was like, we need to make sure we remember these things. Because what do we notice about this one? It's the cubes. This is a sum of cubes. We talked about this several sections ago. We have not had the unit test over that yet, so we gotta not forget that. It's not a difference of cubes. It's a sum of cubes. The formula is not different. It's just when we use our soap. Because it's cubes. So this is the same as that x has been cubed. And the 125 came from 5 being cubed, right? I might switch the colors on that so we see. Right? When we're writing out our formula, we're going to have a short one and a long one. It is not 3 versions of the difference of square pair of factors. The first one looks like the difference of square stuff, where I have the same as my first term and my last term. And it uses the same sign. Oop. And we use our soap. So it has the same sign, so it's going to have a plus. The second piece is a trinomial, where I have my first piece squared, so x squared. We use the opposite sign, so this one's going to have a minus. first times last, x times 5, also known as 5x. And then our last sign is always positive, and it's our last term squared. 5 squared, 25.
What does sum stand for?
Sum just means it was an addition.
I mean, sorry, so.
So same, opposite, always positive. It's the signs we use. With our sum or difference of cubes, the only difference is SOAP. It changes the signs. All the terms themselves to be the same. So if we're asked to solve, this is not done. We can't stop here. We need to get to x equals. This one, not hard. What's our solution going to be for x plus 5? X equals negative 5. We get that by setting it equal to 0. We can set this up as x plus 5 equals 0. Subtract 5 from both sides, get x equals negative 5. That is one of our solutions. Easy peasy. The right-hand one, the quadratic term, will it factor? It will not factor. So we're going to use the quadratic formula. So we're going to have our x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, right on the edge there. There we go, over 2a. 2 times 1. So we're going to simplify these. 5 times, we're going to have 5 plus or minus. What do we get inside the radical? Negative 75. We need to simplify that radical.
Wait, does the imaginary number go before the radical or after?
Before. So if we were to split this up, I could rewrite 75 as negative 1 times 25 times 3, right? So that's a product of 75. The reason I do it like that, so we can think this as 5 plus or minus 5i square root of 3. I can take the 25 through the square root. I can take the square root of that. The square root of negative 1 is I. And that'll be our solution. Okay. We will do one more of these kind of tomorrow because there's a funky factoring thing I want us to, or a funky solving thing. I want us to do one, but I don't want to have to rush it. So I am going to push the homework back a day because the number 54 on the homework looks like this. You might be able to do it, especially if you've been introduced to doing like a U substitution. If that is not a familiar phrase to you, we will do it at the start of the day tomorrow. That'll be our first one we do, okay? And that'll be the very last thing on 2-4. So I'll push the homework back a day since we're not going to touch it before the homework's due. Okay? So we'll do like number 54 on the homework. Everything else, we've done something like it. Please make sure that you have done the IU registration, which is the email from acp@indiana.edu, because that is not the registration for the class. That's just the creation of your account. So by the end of this week, we will be doing the registration for the class. And if you have not created your account, you won't be able to register because it takes them 24 hours to get it set up and for you to be able to register. So make sure you set up that account so we can register for the course. You have to have the account even if you don't register with IU. But you're doing all the work, so why not?
Just kind of
What's up? Huh? It's different. It's a separate account because it gets set up through IU. So you should have an email from acp@indiana.edu to get you registered. Yes.